Hi guys, how are you doing? Here's the second lesson, okay? The title is Diffusion, as you can see. Uh, we're gonna learn what happens, okay, when we talk about the process of diffusion, and we're gonna explain how the atoms move and how can we increase diffusion by changing uh, different things, okay? We can change different things so diffusion might happen faster or slower, okay? So the keywords that we're going to learn today is diffusion, kinetic energy, high to low concentration, temperature, stirring, equilibrium, solvent, solute, and solution, okay? Again, I recommend you to go all over these keywords and try to define them and put examples, okay? Don't worry, we will go slowly and we will be able to know at the end what diffusion means. Okay, what's the meaning of diffusion? So the first thing to diffusion is the movement of a substance from high to low concentration in order to reach an equilibrium. Okay, one example of that, okay, is when you add perfume. When you add perfume, just got it here. So when you add perfume, the container has a high concentration of molecules. Okay, these molecules are high. My nose is far away, so my nose cannot detect these molecules. But when you spray yourself, okay, you spray yourself, you smell it. Okay, now I haven't sprayed, but I am able to smell it. Okay, so I recommend you now to go and grab one perfume spray that you have at home, okay? And then you spray it facing outside, okay? A couple of times. And then you should wait till the scent reaches your nose, okay? That's the particles here that are in a high concentration, okay? Now I can smell it, okay? They're trying to occupy the maximum area, okay? Remember, gases have a lot of kinetic energy. This is liquid, but when we spray it, we're vaporizing that liquid, so it mixes with the air molecules, and then because the air molecules are constantly moving, they reach our noses, okay? That's diffusion from high to low concentration. Also, this happens in liquids, but also with solids. It happens with liquids, gas, and liquids and solids. Okay, so the liquid, when it gets vaporized, they can mix with all the gas molecules. And also, this is really familiar for you, so you can do diffusion like this. And also, this one, okay? We're gonna use this one a lot during this lockdown, guys. Colacao in the morning, okay? So this is what? This is the solute, okay? The solute, you can now, for solid, you can say colacao, and for solvent, which is the substance that dissolves the solute in it, it can be milk, okay? I don't know if you have had experienced that in your lives, but this is, so here I have 2 glasses of milk, okay? I have 2 glasses of milk. One has hot milk, the other one still fuming, okay? And the other one has cold milk. So what I'm gonna do, I'm gonna put 1 spoon of the solute into the solvent and then see what happens, okay? So I'm going to add now 1 spoon into the cold milk, okay? So when I add it and I stir it, what happens? It's like the milk is not dissolving this really well, so the milk is turning brown a little bit, but not at all, okay? So all the solid stuff stills on the top, okay? And we don't want this. We don't want this. Has changed a little bit, but not fast. I mean, it takes time for you. You should stir this a lot till changes. How can you increase this? How can you speed up the reaction? You can speed up the reaction by adding or heating up the milk. Okay, let's see now how fast it turns into hot chocolate. Like, look, now it's changing faster. Okay, so diffusion can be helped if we change the temperature. Okay, so for high temperatures, and then you can compare them, which one has dissolved better is this one. Okay, and this has only also remains of the solute which hasn't dissolved. Okay, so diffusion in gases, diffusion in liquids, diffusion in solid into liquids. Okay, remember what we are changing is the kinetic energy. So if we increase the temperature, the kinetic energy will increase. Okay, for example, here there is another experience that you can do. I don't know if you have food coloring at home, but you can do something like that, and it looks quite cool, quite amazing. This is the thing I want to show you in a minute. Okay, so this is the diffusion GIF I've downloaded for you, so you can see. Here we have high concentration of ink, and here we have low concentration of ink. The high concentration of ink goes down, trying to maximize, to occupy, and get to an equilibrium. Look at here, equilibrium. Okay, so at the end, the whole thing will become blue. Here we have another example of diffusion. Okay, here were molecules go from high concentration to low concentration, trying to reach the maximum space and trying to reach the equilibrium. Remember, temperature adds movement, adds energy. They will bounce faster. So you will, for example, smell it quicker. So you will smell this quicker in summer than in winter. Okay? You will dissolve chocolate faster if it's hot than if it's cold. Okay, perfect. And that's a give. Okay, and another thing is this one. Okay, this is the other gift I wanted to show you, which is, sorry, so basically this is showing to you what happens, yeah, when we remove, yeah, we have low concentration on the top, high concentration in the middle. Okay, we remove, like we are opening, like your mom is cooking, and then you open the door and all the food molecules reach your nose, trying to get an equilibrium. Like underneath you will see the overall process. Okay, and this can be done at home. Okay, like you can do any of the practicals I show you, like colacao, hot chocolate in milk, and perfume. You can spray and then time how long does your mom take to smell that. You can play up with your family, like mom, brother, sister. Okay, and then after that, what I want you is to complete these activities. Okay, explaining how diffusion happens from where to where, and the factors that increase or decrease the rate of diffusion. Okay, so everything is on Google Classroom. Complete all the activities and submit them, upload them after you complete them into the right assessment. Okay, guys, hopefully diffusion is good. So let's see you in the next lesson. Bye, guys.